Looks like recording is working, sound is working. Been a long time. Super busy, which is a good thing. This is a PSA announcement for owners of electronics who want to practice soldering. Perfect example of what not to do. And I'm going to show you how we're going to fix this. This fine specimen here is an ACER Swift X, I believe. Came to me because the owner decided they were going to try their hand at soldering a new DC jack on the board, and well, things didn't go very well. Not super familiar with the Swifts, but it's got a Ryzen 7 RTX graphics card, so yeah, it's probably let's say a fairly pricey laptop. Anyway, like I said, it came to me in pieces. Here's the problem. Here's the port in question. I'm going to attempt to go to microscope camera and see if I can show you exactly what happened. So, judging from the looks, let me see, it looks super clear for me. Let me see if I can clear things up for you. So yeah, judging from the looks of that, they had inadequate heat. And they have severely damaged this port. Doesn't look like they damaged anything else, luckily. But this port is a mess. So that's the top side, and then the bottom is no better. Ouch. So if I had to guess, I would say probably not enough heat, not enough patience. Got a little frustrated, and luckily they gave up before they did any more damage. We're going to see if we can rectify this situation, and we are going to do it without hot air. Now, if you're going to attempt this repair yourself and you are a hobbyist electronics person, or, you know, a device owner who just wants to practice, there's something out there called low melt solder, and I would highly recommend you give it a shot. I think that's what we're going to use in this case. We're going to put some low melt solder on here, see if we can't clean this mess up and get a new port on here for the owner. I'm going to turn my fume extractor on. I got, since I've done my last video, I've gotten some new equipment. Can't really show you, well, maybe I can. Just give me a minute. Let me grab my other camera. I'm not trying to brag as much as I am just showing how proud I am that I finally stepped up my game and got a new proper fume extractor. For a long time I was running the little Hako or Hako, whatever, however you want to pronounce it, little fume extractor thing that you set on top of the desk. I decided to upgrade and get an actual fume extractor with a 3-stage filtering system on it, and I also did away with my, as I drop my camera and break everything. That's wonderful. I just smacked my receiver for my microphone. That's great. Didn't break anything, luckily. Anyway, I decided to graduate from the Hacko FX951 soldering station that I've grown to love and been comfortable with for the past 4 or 5 years. I decided to upgrade to a Weller station based on some reviews from some other people who are in this line of work and comments from others. I decided to pull the trigger and get a professional Weller soldering station. Just give me a second. I'm setting up my camera here so I can show you. Setting up my other camera here. We'll see if we can switch to it. Really have this planned out. Let's see. Face cam. There we go. Yeah, you can see it there. Got the WX base, WX2 base, Weller with the 2 soldering irons and everything. Yeah, so you can see that. And then I also got, pardon the camera, I got an actual solder station, or fume extractor. It's a Vivor brand. It's a box that's underneath the desk. You can't really see it because it's kind of dark, but anyway, I had to drill a hole in the bench and get this pipe up here, so really happy about that. But anyway, enough about that. Let's go back to this mess. All right, let me get that camera out of the way, and we're going to turn the fume extractor on, so it's going to make a little noise. We're going to see if we can fix this port. We're going to put some flux on here. I don't think there's any components that are gone, but we're going to try to use some low melt solder. See if I can get this to focus a little better. I think the next thing I'm going to do is upgrade my microscope camera and stuff. That setup, because this is an AMScope camera, and I spent a lot of money on it, but for some reason doesn't seem to work too well with my current situation. So I'm gonna get a replacement. Anyway, all right, let's go see if we can get this port taken care of. We're just going to put some low melt solder on here. And I do apologize if the camera view is not spectacular. In theory, low melt should be able to let this port just drop right out. Potentially. And if not, it's going to lower the melting temperature enough to where if we used hot air, it would come right out. Just takes a little patience. God, that's very blurry. Promise it doesn't look that blurry in my microscope. I just don't know what's going on. All this melted plastic, I'm not sure this port is going to come right out. I mean, these rear pins are loose and everything, but this plastic back here is so melted that it's probably making the port stick. So we may have to hot air this out in this situation. See the top of that is ripped out. So yeah, we're gonna get our little stand out and prop this board up if we can. Let's see if we can get this port out using hot air, because it's so damaged. I don't think there's going to be another way. So we're going to get our logic board, our motherboard propped into this jig real quick here. We're going to hot air it off. Actually, I think I'm going to turn the board around, so just give me a minute. So we can point the hot air off the edge of the board, not ruin anything else. Jeez, that looks so horrible. I apologize. Alright, let's see what we can do here. I'm just gently pushing on this. Jeez. Now to turn up the heat, I may have to actually melt the plastic on the back of that port. It is so melted and stuff, it's holding the port in. Gotta turn the air speed up. There we go. God, if only this was smell-o-vision. This stinks. And the port just disintegrated. All right. We got it out. Wonderful. It was broke into 5 or 6 pieces. All the plastic, melted plastic, was holding it in. May have to run a wire to this. That's not good. This is all ripped. Yeah. That pin's... That part is not good. We're going to clean this area up though. This is why I went with the dual station, is because now I can pull out another iron. Don't have to switch tips. Already got another iron ready. Come on, wake up. There we go. These pencils from Weller have like a sensor, like a motion sensor, something that turns them on. We'll just gently clean these out. No stress. Yep, we are going to have to run a wire there, which is not a big deal. That's what I love about this fume extractor too. I'm pretty far away from it. It still pulls that smoke away from my face. I'm 6-7 inches away from the entrance and it's still so awesome. It just pulls the smoke away. It's wonderful. Love it. I do still have my Hawker, my old FX 951 station. Probably going to keep it around for a while until I get used to this, completely used to this Weller. So now we can survey the damage here. And all that solder mask missing is not that big of a deal because that anchor point is for ground, so you can see that it's not a huge deal. I know I need to upgrade my lighting situation in my microscope. Doesn't look like we got any missing components either ripped off. Let's check. Did I get this desoldered? Doesn't look like it. That's okay. We'll flip the board over and take care of that. Not a problem. That's unfortunate that pad got ripped, but that's okay. We can work with it. The main thing is just getting everything cleaned up. There's the destroyed port. We'll just get rid of all that mess. Let's see what we can do for this side. Do some cleanup on this side as well. This board is bent slightly, but should be fine once it goes back in the chassis. Looks like we might have to put some solder in this hole down here. That nice and warm. If that doesn't work, it's not a big deal. We'll just get some more low melt. I am going to use low melt in this case because this port area is so damaged already. I don't want to make it worse. So. I have to look at the schematic for this ACER Swift to see what this pin is. Not sure what it goes to. I know the one in the middle is the actual power. Put a little more flux in there. Patience is the key. There we go. You got it. I believe that could be ground. Which, if that's the case, it's not that important, since we have the two anchor points which are tied to ground. And it is. That's ground, so not as important as this. The busted pin on the other side, that's important. We'll definitely have to connect that. So managed to clean this up pretty well, given the circumstances. Looks like they were really wrenching on this thing and damaged the ground plane right here. Ripped up the solder mask, obviously. Bent the board up real good. But like I said, we all start somewhere. I'm not going to beat them up too much over that. It's kind of different when you're somebody who does this day in and day out. Alright, doesn't look too bad. This looks like this goes to some kind of MOSFET right here. So we'll just have to add some extra solder there, figure out how we can get that connected. Should be okay. Get the new port out here in a second. Get that resoldered. I'm going to refrain from using Q-tips too much because of all these little ESD protection diodes over here behind this USB-C port. You get cotton swab fibers stuck on those, and you can rip those off pretty easy. They're very fragile little creatures. All right, where's the new port? Here's what the port should look like. So we're going to go ahead and get that new one soldered on there and do a preliminary test. I'm not going to I don't have all the parts to this computer to put the board back in, so we're just going to kind of have to go with it. Alright, I think I'm going to apply some, yeah, look, that looks nice. That fits in there just nice. I'm going to get some Kapton tape and tape that port in to keep it from moving while I'm soldering it. A little trick. It's not meant to like hold it in there super tight. Just meant to give you a little. Yeah, that's not gonna work. Alright, we're gonna do it the other way. Get out of here, Kapton tape. Get off me. We're gonna do the finger burning method. What we'll do is grab our solder. We're going to do this like Big Clive. Hold the port and the solder with one hand and the soldering iron with the other. Not sure this iron is going to be big enough. Enough heat transfer. We'll use the big one again. Put some more flux on this. Quit being stingy with the flux. Hot. Well, that transfers heat real quick. Yow. Okay. This soldering iron tip is ridiculously too big. Probably should have put solder mask there, but that's okay. Alright, let's flip it over and see how we're doing. Okay. Probably a little bit more on those front anchors. Could always flip it over and do it on this side with the little iron. This thing really doesn't want to, this little tip doesn't want to transfer heat very well. Alright, back to the big one. I apologize for the shoddy camera work. See what we got now on that one. Oh yeah, it's through. I just want to double, triple check, make sure that these front anchor points are soldered very well. Those are what pretty much take all the damage from plugging and unplugging. Put a little more solder on there. There we go. Let's see how that looks. I like it. I'm happy. Yeah, that looks nice. Yep. I'm happy about that. It's nice and solid. I know this is just a simple DC power jack, but still. Nice and solid. Now, we have one more thing to address. That's bridging the gap. We got a bit, well, you can't see what I'm talking about. Brighten it up a little bit, see if we can show you. There you go, you can see it right here. We've got a little gap between this connection and that solder. We're going to try to see if we can blob some solder on there first. We'll try that and see if that works. If not, we'll have to put a piece of wire there or something to connect those 2 points. So we're going to get a bunch of flux. Unfortunately, don't think it's going to happen, so we're going to have to cut. We're going to have to use a piece of jumper wire. And this wire's too big. That's a fat piece of wire, but where did that go? Shot a piece of copper on my shirt. Alright. Gosh, that's still too big. I think that wire's too thick. We're going to use a regular jumper wire, the 40 gauge. Since that is not power. I think a regular size jumper wire will be fine. More flux on here. There we go. Ha! We jumped it. It's a nice bridge between those 2 points now. Maybe. I don't know, I was just wiggling that and it seems like it's coming loose. Soldered. All right. Cool. I know that's loud. All right, where's my brush? I can clean this off. Cool. Everything's clean. All right. See if I got. No, they didn't give me the charger. I have to see if I got a charger or if I got a DC jack setup I can use to power the board and see if it works. Get any current draw or anything. I do have part of the laptop, so we could, in theory, see if it turns on. We're going to go ahead and do that. We'll go ahead and we'll slap the board back in real quick and see. And to make things interesting, we won't even use the battery. We'll just use the DC jack. Okay, I know I'm doing something wrong here. My board is not cooperating. Let's see. Bear with me for a minute. I am trying to plug stuff in and make sure the board doesn't fall out. Bear with me while I try to get this cable in. ACERs are not known for being completely repair friendly. All right. I think we got the board in there enough. Going to gently open it. I'm going to get it just to where you can see me plug the DC jack in. All right. I got to get my power supply down. See if I can get that. Got the trusty Wamptech 20 volt 10 amp power supply I use to power on laptops. Let's see if I can get I need a DC cord and a ACER Swift plug for that. I'm just curious if this thing turns on or not. Obviously, our ultimate goal is for it to power on. Plug in positive and negative here. Need to run a DC cord or power cord to our power supply. Get this all tangled up. This is kind of off the cuff, so that's not going to sit up there. I'm gonna have to hold it or put it on the floor. Come on. Power cord in the trash can. Let's see. I have no idea what an ACER Swift plug looks like. Just a second, I'm gonna have to Google it. Can I get a picture of the plug-in? $3 mil by 1.1 mil. Oof, that's tiny. Let's see, is it this one? Let's see. Turn on the power supply. $20 volts, 3.5 amps. Okay. We're drawing 0 amps. That's okay, I gotta hit the power button. Where's the power button? Be careful, this thing's fragile. There's no screws in the hinges. Come on. Stupid fuel extractor. There's the power button. See lights. 1.3 amps. Okay. It's drawing 1 amp. CPU's warm. We're gonna get a I'm gonna put my power supply here. Picture on the screen maybe? See, keyboard's lit up. Hmm. Looks like the LCD's plugged in. Oh yeah, this thing does have a CMOS battery. I hope to God the flipping, I don't want to jinx myself, but I hope the BIOS is not corrupt. Alright, let's try this again. Yeah, it's drawing an amp. 1.4 amps. So it's doing something. Not exactly sure what. Oh, I saw that. I saw an ACER logo flash. There we go. No bootable device, so it's working. Looks like we fixed it. The hard drive's not in there. Let me see, I'll put the hard drive in. I'm gonna have to move the computer though. I don't want their personal information revealed. So I'm gonna have to move this for a second. Just want to make sure their drive boots up. Depending on what shows on the screen, I will show what I see. Looks like the SSD gets plugged in right here. I'm gonna screw the SSD in and turn it back on, and I'll show. If all's good, I'll show like a desktop or something just to show it's working. And then I don't have the bottom cover or anything, so I'm not sure I'm gonna put this machine back together fully. I do got to be careful for this hinge though, because these things will break. Alright, I'm going to power this back on. Kind of wondering if I should solder mask that. Put some solder mask on the back of that port. I'm thinking no, because the only thing that's really exposed is the ground plane. That's not going to hurt anything. Did I hit the power button? I did. What are you doing? There we go. ACER popped up. This machine has definitely seen better days, but hey. Why are you shutting off? Come on. Turn on. You were just booting a second ago. Stop playing. There you go. We got a spinny animation here with the ACER logo. Might have to check the CMOS battery, make sure that's still good. Hurry up. Come on. This is an hour-long video just to replace a DC jack. What are you doing? I would show you the spinning circle with ACER logo, but I don't. In case their desktop pops up, I don't want to accidentally flash that and have to edit this video. Oh. Spinny logo. Holy moly, what are you thinking about, huh? What is it you're trying to process, little ACER? There we go. Wednesday, December 20th. Oof, CPU's getting hot. Come on, hurry up. Is this a touchscreen? No. I try to sleep it. Anyway, I was trying to figure out a way to cover it. I used some DC jacks. Anyway, I was going to show you. Ta-da! It's working! Alright, I'm going to turn it off because the CPU is getting hot. And I don't have the fan installed. And as you can see, no battery. Anyway, we're going to call this fixed. I'm going to tidy this up a little bit and send out the invoice and get this back to the client. So, I want to thank you for watching. This is Tim. See you in the next video.